Hello everyone, this is from the Chinese University of Hong Kong Shenzhen. Previously, we designed a freeform modular self-reconfigurable robots, FreeBOT. In this presentation, I will introduce our recent progress, an energy sharing mechanism for FreeBOT. In recent years, distributed robotic systems have been widely studied and applied. But the inconsistent residual energy of agents affects the sustainable work of the system. Based on the assumption that agents in the system can share energy, some theoretical work demonstrate the benefits of energy sharing in distributed robotic systems. However, these exciting studies are still at the simulation stage, and very few have been reported about the implementation of energy sharing in realistic robotic systems. MRSR are a special class of distributed robotic systems that can rearrange the modules to change into different configurations. Robotic modules are combined to generate system functions. Therefore, it is more meaningful to realize energy sharing on MRSR. Most of MRSR are with fixed position connectors, and they can be easily extended into a switchable real-time energy transfer channel. FreeBOT is a MRSR with arbitrary connection points, while the modules can freely connect through a spherical shell and magnets. However, battery management of FreeBOT is difficult due to the spherical shell covering. It is conceivable that there are greater challenges in implementing energy sharing on such a MRSR that cannot directly manage batteries. To operate the battery directly, from the outside of the FreeBOT, we added a switchable brush mechanism, which is essentially a conductive spring that connects the internal vehicle to the shell in a tight and movable manner. In addition, there is a polarity conversion circuit between the charging contact and the battery. The battery polarity is matched to that from the outside by the polarity conversion circuit. Then, we propose corresponding energy sharing rules to adjust the network topology and transform the random network into a safe and effective energy sharing network. First, we describe the topology of the network based on an undirected graph. The incidence matrix equivalently represents the topology of the battery network formed directly by the real robot. After that, with the incidence matrix, we can find some invalid components in the network. Following the proposed strategy, we can simplify the proposed network into an effective one by placing some robots in open circuit mode. We take this case as an example to demonstrate the proposed energy sharing rule. First, we describing topology with graph theory. Both the graph and the incidence matrix can equivalently represent the energy sharing network. Then we start to convert the network to the effective one. In step 1, we break this cycle by breaking E1. In step 2, the sum of column E8 is not 2, so E8 has a short circuit. In step 3, the sum of row V4 is 1, indicating that V4 has an open circuit, so V4 and E3 are deleted, similar for V2 and E4. Finally, an effective energy sharing network is obtained. In the simplified network, robots 2, 5, and 7 are in the V1-V3 subnet, while robots 6 and 9 are in the V3-V5 subnet. Further, we provide several types of networks that are arranged in such a way as to maximize the number of robots joining the energy sharing network. We calculate the pose constraints of the robots joining these networks. This can be used as a reference for some more applications. We have done experiments on our robots, and the proposed mechanism can effectively share energy in the robot. The charge state of robots in the same subnet will eventually reach a balance. In this paper, we propose an energy sharing mechanism for FreeBOT that allows each robot to share energy with peers through surface contact. This is the first solution to the energy sharing problem for 3D freeform robots. Some aspects can be further improved in the future. First, the proposed energy sharing solution is only applicable to static configurations. Second, the proposed rules require centralized information. Currently, it is obtained mainly through external sensors. Overall, although this work has some limitations, it is the only solution for FreeBOT energy sharing so far. We will further investigate better solutions in the future to solve the above limitations. That is all. Thanks for your attention.